Hi there. In this video, we're going to look at the question. It is a mixed question with the arithmetic and geometric sequence. So if you look at the question, it says the geometric progression has first term A and the common ratio R, the first, second, and the fourth terms of a geometric progressions are the first three terms of an arithmetic progression, and we're supposed to show that r minus 1 times r squared plus r minus 1 should be equal to 0. Okay, so first of all, we will look at what information we have for geometric progression. So since you can see for geometric progression, it is giving us the first term. So just recall the formula: an is equal to a1 r to the power n minus 1. So from here we can see clearly the a1, the first term is a, a2 must be ar, and a4 is ar cube. Then right after this, it says these terms of a geometric progression form the first three terms of an arithmetic progression. So now for that one, we can form arithmetic progression from here, which will be u1 will be equal to the first term of geometric, sorry. u2 is equal to ar, and u3 is equal to ar cube. Okay, so from here we can see we know arithmetic progression. So arithmetic progression terms, and if the sequence is arithmetic, then we know the difference should be common. So that means the second difference, second term minus the first term, and the third term minus the second term. So just rearrange them. From here you can see a is common throughout. So you will get r cube minus 2r plus 1 is equal to 0, and this r cube minus 2r plus 1 is equal to 0, and this can be written as r minus 1 r squared plus r minus 1 is equal to 0. So we are able to prove r minus 1 times r squared plus r minus 1 is equal to 0. So from here, if we look at the B part, so it says given that the sum to infinite given that the sum to infinity of the geometric progression is finite, find the exact value of r. So then from here, if you remember by definition, so this r absolute is less than 1, so that's mean r should be greater than minus 1 and less than 1. So now we are trying to look for the values of this. So r minus 1 times r squared plus r minus 1 is equal to 0. So from here, r minus 1 is equal to 0, or r squared plus r minus 1 is equal to 0. So right from there, you can see r is equal to 1, or r is equal to, if we solve this quadratic equation, so we are gonna get minus 1 plus square root 5 over 2, or r is equal to minus 1 minus root 5 over 2. So then if you remember this definition here, so r absolute, so that's mean r should be greater than minus 1 and less than 1. So that's mean we are not going to take this value, and if you simplify this one, so this is 0.618, and if you simplify this one, so this will be around negative 1.6. So that's mean we are not able to take this value, so the only option we have is r is equal to minus 1 plus root 5 over 2. Since it says the exact value, so we will take this as an answer. Okay, so now let's have a look on C part for this question. So it says find the sum to infinity of a geometric progression in terms of A. So let's recall the formula. You remember it's a1 over 1 minus r. Then you have all the information, so let's plug the values. So s infinity is equal to a1 is a, and then 1 minus, and r is what we just found here, minus 1 plus root 5 over 2. And then from here, if we just simplify this one, so this will be a over 2 plus 1 minus root 5 over 2. And then if we further simplify, so this is 2a over 3 minus root 5. Since you remember, the third fraction will goes to the first fraction, and then this will become 2a over 3 minus root 5. So that's all. Thank you very much. Hope you understood.